Welcome to this session. This session you solve an example involving a third order recurrence relation whose given initial conditions. So, solution. The first step, we assume that this recurrence relation has a solution, an equals to r power n, where r is a non-zero constant. So let a n be r power n be the solution. Let me call this one 1. Where r is a non-zero constant. So by that we mean an minus 1 would be r raised power n minus 1. An minus 2 would be r raised power n minus 2. And an minus 3 would be r raised power n minus 3. And then you call this one equation 2. So what we do next will be to replace ai's for r raised power ni's. So replacing 2 in 1, we get, so where is a n, we put r raised power n is equals to 6 r raised power n minus 1 minus 11 r raised power n minus 2 plus 6 r raised power n minus 3. And because r is taken to be a non-zero constant, then we are allowed to divide through by r raised power n minus 3, r raised power n minus 3, r raised power n minus 3, r raised power n minus 3. So this will give us r power 3 equals to 6 r power 2 minus 11 r and then plus 6 as the answer. And then what we do, we take all the terms to the left hand side. So we'll have r power 3 minus 6r squared plus 11r minus 6 equals to 0. So this is what we call the characteristic equation. Now, our characteristic equation is a cubic equation, and they usually know specific way of factorizing a cubic equation to get the roots of that given equation. We do what we call trial and error, but the trial and error is done with the help of the constant term in the cubic equation. So you write the constant term, like for this case, we have -6, and write all the factors of that constant term, both negative and positive. So factors of -6 are plus or minus 1, plus or minus 2, plus or minus 3, and then plus or minus 6. Even if this sign was plus, we'll have the same factors, plus minus 1, plus minus 2, plus minus 3, plus minus 6. Once we have listed the factors of the constant term, then you use trial and error each of these factors, try to replace into the equation and see whether they satisfy the equation. If you're lucky to find one that satisfies the equation, then it's the one that will help you to factorize that cubic equation into a product of linear terms to be able to give the values of r, or a product of linear and quadratic term. But note that not all cubic equations can be factorized. So some will, some will not. So for example, if we let r to be 1, then we'll have 1 power 3 minus 6 1 squared plus 11 times 1 minus 6. This will be 1 minus 6 plus 11 minus 6. 1 plus 11 is 12, minus 12 is 0. So we are lucky. R equals to 1 is a root. Now, when we say R equals to 1 is a root, then it means R, taking this to the left will be now minus, R minus 1 is a factor of now this cubic polynomial to the left of this equation. R cubed minus 6R squared plus 11R minus 6. So generally, once you are doing this trial and error for cubic, or maybe quartic or quintic equations, once you say that R equals to K is a root of that given equation, then it means taking this to the left, R minus K is a factor of that given polynomial to the left. So we use long division to get the other factor for this cubic equation. So you write R power 3 minus R squared plus 11R minus 6, R minus 1. So you ask yourself, what do you multiply by R to get R cubed? And that is R squared. So R squared times R is R power 3. R squared times minus 1 is minus R squared. And then you subtract, just as we do with normal numbers, R cubed minus R cubed is 0, minus R squared minus R squared. It's like minus 6 plus 1, which is minus 5. And then you bring these terms, minus 11 plus 11R minus 6. So you ask yourself, what do you multiply by this R to get minus 5R squared? And the answer is minus 5R. So minus 5R times this is minus 5R squared. And minus 5R times minus 1 is plus 5R. And then you write this line, and then you do subtraction in the normal way. Minus 5R minus 5R is 0. 11R minus 5R is 6R. Then bring this minus 6. Ask yourself, what do you multiply by this R to get 6R? That should be positive 6. So we'll have 6R. 6 times minus 1 is minus 6. And you should find that when you get this, when you subtract, you get 0. So therefore, it implies that R cubed minus 6R squared plus 11R minus 6 is the same as R minus 1 times R squared minus 5R plus 6. Remember, this was equated to 0. So this quadratic, so let's see, R squared minus 5R plus 6. So product is 6, sum is minus 5. So numbers should be minus 2 and minus 3. So that we'll have R squared minus 2R minus 3R plus 6. So the common here is R minus 2. Common here is 3, so minus 3 into R minus 2. So R minus 2, R minus 3. So this can also be factorized. So this will be the same as R minus 1, R minus 2, R minus 3 equals to 0. Thus, the roots are R1 equals to 1, R2 equals to 2, and R3 equals to 3. So these are case of distinct roots. So you say the general solution is n equals to C1 R1 power n plus C2 R2 power n plus C3 R3 power n, which will be C1 1 power n plus C2 2 power n plus C3 3 power n. So if we were not given the initial conditions, then we stop there. But because we are given the initial conditions, we'll use them to get this constant C1, C2, and C3. So A naught is given by 2. So that means where there's n, we put 0. So we'll have C1, 1 power 0, plus C2, 2 power 0, plus C3, 3 power 0, equals to 2, i.e. C1 plus C2 plus C3 is 2. Call this one equation, say 3. And then A1 is given by 5. So replace where there's n by 5 in this general solution. So C1, 1, replace n by 1, not 5, plus C2 plus C3. This should give us 5. So when you simplify this, you get C1 plus 2C2 plus 3C3 equals to 5. So this is number, call this one 4. And lastly, we were told that A2 is given by 15. So that means that C1, 1 raised power 2, plus C2, 2 raised power 2, plus C3, 3 power 2 should give us 15. So this would be C1 plus 4 C2. 3 squared is 9. C3 is 15. So you get this one as equation 5. So it results into a system of 3 linear equations in 3 unknowns, C1, C2, and C3. So therefore, the problem now turns to be a linear algebra problem. So we solve system 3 to 5. So we have C1 plus C2 plus C3 equals to 2. And then next equation is 1 plus 2 C2 plus 3 C3 equals to 5. And the other one we have C1 plus 4 C2 plus 9 C3 equals to 15. So let's use Gaussian elimination. So write the matrix of this is 1, 1, 1, 1, 2, 3, 1, 4, 9, and then 2, 5, 15. So this is the augmented matrix of this system. Or you can use any other method that you like to solve this system, augmented matrix. So we say at the first step, let's rewrite the same system. So we have 1, 1, 1, 1, 2, 4, 1, 3, 9, 2, 5, 15. So row 1, let it be row 1. Row 2, we expect to have a 0 here. So let's say row 2 minus row 1. Row 3, we also expect to have a 0 here. So we say row 3 minus row 1. That one will give us 1, 1, 1, 2. 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 2 is 3 minus 1 is 2. 5 minus 2 is 3. 1 minus 1 is 0. 4 minus 1 is 3. 9 minus 1 is 8. 15 minus 2 is 13. And then I expect to have a 0 here. So I'll say row 1, I keep it to be row 1. Row 2, I keep it to be row 2. But row 3, I'll say row 3 minus 3 row 2. So this will give me 1, 1, 1, 2, 0, 1, 2, 3. This is 0, 0. 8 minus 3 times 2 is 6. So I'll get 2. Now here I have 13 minus twice. Okay, thrice. So 3 times 3 is 9. This will give me 4. And then to get 1 here, you simply multiply this row by a half. So I say row 1 to be row 1, row 2 to be row 2, row 3 to be a half, row 3. That will lead me or will take me to the matrix 1, 1, 1, 2, 0, 1, 2, 3, 0, 0. This will be 1, this will be 2. So now this is the row echelon form matrix. So from which I have now this first line means C1 plus C2 plus C3 is equals to 2. This means C2 plus 2C3 is 3. And then this one means C3 is 2. So by back substitution, C3 is 2. And then if I replace by 2 here, so I have C2 will be 3 minus 2 times 3. So 3 minus 6, which is minus 3. So C2 is minus. So this is C1, and then 2. So 2 times 2. This is 2 times 2, because C3 is 2. So this is 4. So this is minus 1. So by back substitution, the first thing you see that C3 is 2. And so from this equation, C2 is the same as 3 minus 2 C3, but C3 I put 2. So it will be 3 minus 4, which is minus 1. And C1 is 2 minus C2, so minus 1, minus C3, which is 2. So this is like plus. So 2 plus 1 minus 2 is 1. So therefore, C1 is 1, C2 is negative 1, and C3 is 2. So now we can write the particular solution to that given current relation. So therefore, the particular solution is AM equals to C1 is 1 times 1 raised power n. C2 is minus 1, so minus 1, 2 raised power n plus 2, which is C3, and then 3 raised power n. So 1 power n is always 1, so can be written as 1 minus 2 power n, and then plus 2 times 3 raised power n. So that is the solution to that particular problem. Thank you.